So let's say we have this sum, 1 over 1 plus the square root of 2 plus 1 over square root of 2 plus square root of 3 plus 1 over square root of 3 plus square root of 4 and so on, plus the last term, 1 over the square root of 99 plus square root of 100. So this means there's a total of 99 terms in the sum. How would we go about simplifying this expression? Well, there are no like terms in this sum to combine, and also each term has an irrational denominator, so the first thing we can try is to rationalize the denominator for each term. To do this, we need to multiply both the numerator and denominator of each term by the conjugate of the denominator. So the first term becomes 1 over 1 plus the square root of 2 times 1 minus the square root of 2 over 1 minus the square root of 2. The second term becomes 1 over the square root of 2 plus the square root of 3 times the square root of 2 minus the square root of 3 over the square root of 2 minus the square root of 3. And the third term becomes 1 over the square root of 3 plus the square root of 4 times the square root of 3 minus the square root of 4 over the square root of 3 minus the square root of 4. And this pattern continues until the final term, which becomes 1 over the square root of 99 plus the square root of 100 times square root of 99 minus the square root of 100 over the square root of 99 minus the square root of 100. The first term can be simplified as 1 minus the square root of 2 over 1 minus 2, since in the denominator we're doing the conjugate multiplication, a plus b times a minus b, where a equals 1 and b equals the square root of 2. So the a squared minus b squared in the denominator is just 1 minus 2, since 1 squared is equal to 1 and the square root of 2 squared is just equal to 2. So we can apply this for all the other terms. The second term is just equal to the square root of 2 minus the square root of 3 over 2 minus 3, and the third term is equal to the square root of 3 minus the square root of 4 over 3 minus 4, and so on. And this continues until the final term, which is equal to the square root of 99 minus the square root of 100 over 99 minus 100. So we can simplify this further and rewrite this as 1 minus the square root of 2 over negative 1 plus the square root of 2 minus the square root of 3 over negative 1 plus the square root of 3 minus the square root of 4 over negative 1, and so on until the last term is the square root of 99 minus the square root of 100 over negative 1. We can see that in each term, the denominator is always negative 1, so we can actually combine these terms into a single fraction. So we can rewrite this as 1 minus the square root of 2 plus the square root of 2 minus the square root of 3 plus the square root of 3 minus the square root of 4, and so on until the final two terms plus the square root of 99 minus the square root of 100, and this is all divided by the denominator of negative 1. So we can see that in the previous expression, the second term in the numerator always cancels out with the first term in the numerator of the next term. So you can see that the minus square root of 2 here cancels out with the plus square root of 2 in the next fraction, and the negative square root of 3 here cancels out with the plus square root of 3 in the next fraction, and then minus square root of 4 would cancel out with the plus square root of 4 in the next fraction, and so on until we get to the last term, where the second last term has a minus square root of 99, and that would cancel out with the plus square root of 99 in the last term. Alright, so what this means is that in this combined fraction, we'll have a bunch of terms that will cancel out. So the minus square root of 2 will cancel out with the plus square root of 2 in the next term, and then the minus square root of 3 cancels out with the plus square root of 3, minus square root of 4 cancels out with the plus square root of 4, and so on. And then until we get to the last term, the minus square root of 99 would cancel out with the plus square root of 99 here. So we're just left with two terms, which is 1 and then minus the square root of 100. So really all we're left with is now just 1 minus the square root of 100 divided by negative 1. And we can simplify this further because 100 is a perfect square, so the square root of 100 is just 10. So this is just equal to 1 minus 10 over negative 1. And 1 minus 10 is minus 9, and then minus 9 divided by negative 1 is just equal to 9. So this expression is just equal to 9. So I'll just zoom out so you can see the full solution. So here's the full solution. And The key point here is that the second square root term in the denominator is equal to the first square root term in the next fraction. So, for example, the square root of 2 in the first fraction matches the square root of 2 in the second fraction. So this ensures that we can do this nice cancellation of each term, besides the first and last terms, of course. The equal difference for each pair of square roots in each fraction, for example, the 2 and 3 in the second fraction has a difference of 1, and so does 3 and 4 in the third fraction, and so on, ensures that the denominator for each term will be the same when we do the conjugate multiplication. So these two things combined allows us to actually combine all terms into a single fraction and then cancel out a bunch of terms. That's the general format for how we can spot these kinds of square root sums that can be simplified with canceling terms. So here's another sum for you. How do we simplify 1 over 1 plus the square root of 3 plus 1 over the square root of 3 plus the square root of 5 plus 1 over square root of 5 plus the square root of 7, and so on until the last term, 1 over square root of 119 plus square root of 121. The sum has a total of 61 terms, and you can see that the second square root in each fraction matches the first square root in the next fraction. So we have this nice pattern of 1, 3, 3, 5, 5, 7, and so on for all the square roots. And each pair of square roots has a difference of 2. So this means we can simplify this sum using a bunch of cancellation. Alright, so the first thing to do is to rationalize the denominator for each term. So in the first term, we need to multiply the top and bottom parts of the fraction by the conjugate of 1 plus square root of 3. So we multiply this by 1 minus the square root of 3 over 1 minus the square root of 3. And we do that for the second term as well. And we'll multiply this throughout by the square root of 3 minus the square root of 5 over the square root of 3 minus the square root of 5. And then we'll multiply the third term throughout by the square root of 5 minus the square root of 7 over the square root of 5 minus the square root of 7. And we keep doing this until the last term, and then we multiply that throughout by the square root of 119 minus the square root of 121 over the square root of 119 minus the square root of 121. Now we can simplify each term. The first term becomes 1 minus the square root of 3 over 1 minus 3. The second term becomes square root of 3 minus the square root of 5 over 3 minus 5, and so on. The third term becomes square root of 5 minus the square root of 7 over 5 minus 7, and this continues until the last term, which becomes the square root of 119 minus the square root of 121 over 119 minus 121. So now we can simplify this further because the denominator for each term is always negative 2. So this is just 1 minus the square root of 3 over negative 2 plus square root of 3 minus the square root of 5 over negative 2 plus square root of 5 minus the square root of 7 over negative 2, and so on, plus the square root of 119 minus the square root of 121 over negative 2. So we can combine this fraction and rewrite this as 1 minus the square root of 3 plus the square root of 3 minus the square root of 5 plus the square root of 5 minus the square root of 7, and so on, plus the square root of 119 minus the square root of 121. And all of this is divided by the denominator of negative 2. So now a lot of terms cancel out. The minus square root of 3 cancels out with the plus square root of 3. The minus square root of 5 cancels out with the plus square root of 5, and so on, until the second last term, where the minus square root of 119 in the previous term would cancel out with the plus square root of 119. So now in the numerator, we're just left with two terms, 1 minus the square root of 121. This fraction now just simplifies to 1 minus the square root of 121 over negative 2, and 121 is equal to 11 squared, so this is just 1 minus 11 over negative 2, and 1 minus 11 is equal to negative 10, and then negative 10 divided by negative 2 is equal to 5. So this entire sum is just equal to 5. So I'll zoom out once more so you can see the entire solution. So this is really interesting because in both sums, we had a bunch of irrational terms, but when you added all of them up, we ended up with not only a rational number, but also an integer. Of course, this doesn't always work, and the two sums we covered were a special class of radical sums where we could cancel out all the terms in the middle, leaving us with only the first and last terms.